Hello everyone, in this video you learn how to code mergesort in C, and here we've got the original numbers you can see on this prompt. And so in last video I told you that mergesort consists of division part and sorting part. So you need to calculate middle index to um, first break the original array into two subarrays. So to calculate, you can add the first index and right index and divide it by 2. And for right subarray, if you apply the same method, then um, the index for number 7 in the original array is 4, and the right index for number 6 is at index 6 in the original array. So if you add these two and divide it by 2, then it's gonna return number 5, which is the index of the middle number 12 in the right subarray. So let's calculate mid as left index plus right index and divide it by 2. And let's calculate. Let's save the left index in variable, right index assign index 6, and let's print out this mid what is stored in mid variable that our calculation is correct. And the mid value is 3. And let's print out the left subarray and right subarray. So for int from starting from left index and until it is less than or equal to mid, and printf, and let's distinguish the left subarray and right subarray with this bar symbol. And from because the right subarray starts from mid plus 1 at index 4, so int I is mid plus 1 until it is less than or equal to right index. Printf, and let's see the result. So they are printing out the left subarray and right subarray. So we need to repeat this process to each left subarray and right subarray. And let's define a function void mergesort. And because we are gonna pass the original array int array, and let's copy these statements and paste it in this mergesort procedure, and let's call this procedure mergesort array. Compile again and see the result. So let's do this to left subarray. So we need to pass the left index, right index to this mergesort. So let's modify this function as int left index and int right index, having two parameters, and let's remove these two. And because in mergesort, let's pass 0 and index 6 is the index. If you look at here, the index not number 6, so don't be confused, and let's see the result again. So it's correct, returning the same result. And let's call this again mergesort. And now we are gonna break this left array and pass left index. And because the right index for this left subarray is mid, so let's pass the mid and see the result. And it's looping forever, so we need a sentinel to stop this iteration at some point, and the value should the function should stop if this left index gets equal to right index. So we are gonna only call this procedure only if this left index is less than right index. So let's compile again and see the result. So this time 5931 to let's put new line here to say better, and uh, run again. So 5931, this left subarray is broken into 59, and at this time this mid is number 1, and when mid is 0 only printing out left subarray, and because this is left with only one element, so this one stops. And what we are gonna do is that we are gonna apply this process to this right subarray. So we can just call this function once this division process for the left subarray is finished to this right subarray sort array, and mid see remember that right subindex right subarray starts from mid plus 1, so mid plus 1 pass for left index and right index, and let's see the result. Compile again and run. So going up 531 5931 broken into left subarray, right subarray for this left subarray, and it is repeated to 595 and left with only 9 one element, and for this one they are broken into 3 1 and 3 and 1, and here when mid is 15, see mid is when let me repeat that. When mid is number 5, looking at here, when number mid is 5, 7, 12, and 6, this is what happened here, 7, 12, and 6. So it's applied this breaking down applied to this right subarray. So going down 7, 12, 7, 12, and 6. So because we've done division process, and if you remember last time, once this division process is finished, what we gotta do is that is we gotta sort now. So we are gonna push the smaller element first in each by comparing the first element in each subarray. So this one, because 5 is smaller, so it's just this here, and then 9 is pushed at this index, and they are replaced. And after that, because this number 1 is smaller than number 3, it's pushed here, and right, this number 3 is pushed after number 1, and then they are replaced the to the original index. It replaced the original index. So let's print out this left and right subarrays once they are all broken down. So that is finish the division process. So I just copied these statements above statements and just pasted it down here. And let's compile again. And print out. So going up this time, it prints out the left and right subarray once they are all divided. So after they are left with only one element, so 5 9 left subarray 5 9. So we are gonna sort from here. So when they have only one element, they can just stay there. And for this 3 1 and left subarray right subarray 3 1, we are gonna swap these two. And let's do that. So let's declare two array variables, int left and int right. And let's declare left size, and left size will be mid minus, and let's go to earlier slide. It's mid minus left index is 3 and plus 1, so mid minus left index plus 1 will return the size of left subarray, and int right size, right index minus mid index minus mid, 6 minus 3 will return number 3, so they will return the size for right subarray. So let's declare with left subarray with the left size and right subarray with right size, and let's check whether they are entered correctly. So once we add starting from left index, so because this, when you declare a new array, the index starts from 0, so left I minus left index is gonna push the element in array I starting from 0 index. And let's remove this plus sign down here, and let's comment it out just for now. And for right subarray, let's add remove this new line, left right I and minus mid minus 1. This is just for the same reason for the above left subarray, because declaring right subarray is the index starts from 0. So assign array I, and let's compile again that things are working fine. And we can just see mid values here, and let's remove this mid values now, and let's print out what is stored in left subarray and right subarray from I equals 0, I is less than left size, f %d left I, and let's comment this back in, and for int I equal 0, I less than right size, and this time let's print out elements in right subarray, And let's put new line down here to make it clear, and compile again and run, and see left 5, um, left and left right, left left right, 5 9 5 9 and 3 1, and these are left for these two subarrays, and 7 12 7 12 and 7 12 6. So we stored all the subarray elements into left and right subarray, and starting from let's declare three variables int j, and we are gonna store this 0, and which will index the elements in left subarray, and for k gonna index what is in the right subarray, and int l we are gonna store assign left index, because this is the index where the original array index starts from. So while j is that's the left side, and k is that's the right side. So this is gonna loop until one of these left or right subarray is empty. So if this left j is less than, so if this 5 is less than 7, so because it's starting from here, if this 5 is less than 9, if left j is less than right k, then k, this element 5 will be entered in array L assign left j, and we gotta increment j plus plus, and this one index for L should increment, and if this the other way around, which means in this case 3 1 left subarray right subarray, this right is larger, then you need to push this into the first index of the original array, which is in L, so left index. Array L is assigned right k, and this time because you put it in what is in right subarray, you need to increment right index because it will index the smallest value, the first value left in the right subarray. And once this loop is finished, then it'll be left with one subarray, and the elements in this subarray will be all larger than previously pushed in elements to the original array. So while we are not sure, and if the empty or subarray is gonna loop this while if this size is less than the uh, the index that indexes the left, well, the one of the subarrays. So while j is less than left size, then um, array L plus assign um, array not left j and plus plus, and then this loop is gonna finish when j gets um, equal to left size, which means they left subarray is empty, and it's not gonna loop if already this left subarray the element is empty, and while k is less than right size, array k plus plus is assigned right k plus plus should be array l plus plus is assigned with right k plus plus. And because we are finished, let's check if it's compiled alright. And let's print out after merge sort printf the elements to check whether they are sorted correctly. After merge sort, and let's call print array function and print array comma size. So you see, original numbers 5, 9, 3, 1, 7, 12, 6 is sorted in ascending order to 1, 3, 5, 6, 7, 9, 12. So you can see that they are sorted correctly. And let's try with the other elements, and let's go above and remove this um, printf statements that we use to check our results, and let's compile again and see the result. So going back down again, let's try with maybe try with 7 and compile again and run. So this is now wrong. Why do you think so? So the reason is that because this right index is incorrect. So what we gotta do is that we gotta change it to size -1. And let's compile again and run. 59317 is sorted 13579 correctly. And let's try with 3 elements and compile, run. Is correct, the result is correct, and this time try with 4 elements. It's correct, and let's try with 2 elements. It's correct, and this time in reverse order 11, 9, and still correct. So up to here we've learned how to code merge sort in C, and through this step-by-step coding explanation, I hope that you can better understand the inner workings of mergesort and the algorithm. So I'll finish you off here, and thanks for listening. Goodbye.